So we need to, on the set of axes below, graph the following system of inequalities and then state the coordinates of at least one point that's a solution. And so first I need to solve this for y, and the first thing I would do is minus 2x from both sides, and you get negative y is bigger than or equal to negative 2x plus 6. And then divide all of them by negative 1, and you get y. And remember, this inequality, when you divide by a negative number, flips around. And so when you divide by negative 1, that changes that to a positive 2x and changes that to a minus 6. Looking at this again, I subtracted 2x from both sides. Notice when you subtract a negative number, it doesn't change anything. And then I have, this is a negative 1y, and so I divide by negative 1 to cancel those. Divide that by negative 1. That's why it went from negative to positive. And then divide this by negative 1, and that's why it went positive to negative. And notice the inequality changed directions. Anytime you multiply or divide by a negative number, the inequality flips around. So now I could graph this. Y is less than or equal to 2x minus 6. What that means is I start at negative 6. And then this means like 2 over 1. So I go up 2 over 1, up 2 over 1. And then I could keep doing that. I also notice it has an equal sign, so I could draw a straight line. So I could draw a straight line both ways. And then it's also less than, so that means I'm going to shade underneath. So I'm going to take this and shade everything underneath the line. And it goes forever, it's just the graph stops right there. So that would be less than. Now x is greater than 2. Remember, when it's just x without a y, that means a vertical line. So I start at 2. X is 2. X is 2. X is 2. That's what this means. X is 2 everywhere. So it's just a vertical line. It goes straight up and down. And then I see that it's x is bigger than 2, so I shouldn't use a solid line, so I'm going to delete that. What I need instead is a dashed line. So I'm going to do my best here. So dashed. And I guess I could have used the line function, but I'm doing it this way instead. And the reason why it's dashed is because it doesn't have an equal sign. Now greater than, I mean to shade on top, there's really no top here, but that would mean to the right. So I'm going to shade to the right. And so that would be everything to the right of this line. So all of this including all of this. And so now it's kind of hard to see where the shading intersects, but it looks like this area right here, I'll do a different color. This area right here is where the feasible region would be, because it's bigger than 2 and also bigger than there. So this would be the area I'm looking for. The green area. Then it says state the coordinates of a point. So anywhere in the green would be a solution. So let's say here, that'd be a solution. Right here. And that looks to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So one solution would be 5, negative 6. One of many solutions. I went ahead and changed the graph a little bit, and I was looking for the corner. I mean, this is broken up into 4 parts. That's on the right. So I was looking for the area that was to the right of this line, but under this line. And so that area where those two would cross would be this yellow area, and you might see that written as the feasible region. And what that means is anything in the yellow would be a solution to both. Right here is only a solution to the red. Here, none of them work. And here, solution would only work for the blue. So the area that works for both would be the yellow area. We call that the feasible region. And you could pick any point you want in this yellow, and that would be a solution.